Good afternoon, everyone. So I'm going to talk to you guys about Lab 4. And Lab 4 is the oscillating motion lab. So to start, an intro would be that we're tracking the motion of a weight swinging from a spring in 2 dimensions. And then using Newton's second law and the energy principle, we can analyze that motion. And so the results, which we'll get to, but the model and observation were mostly lined up as they should be. So first I want to show you my tracker motion. And you can see that the origin of the axis is up at the top where the spring is at a fixed point, and then at the bottom it swings around in both the x and y direction. And as I play it, you'll see all the little points go, and it starts in the negative x and negative y, and it goes down to the positive x, but even more negative y, and then just kind of spins around just like oscillating motion should be. And you can see all the motion in my table down to the right. And so now I want to show you the code for all this stuff. So we start with the basic stuff that everyone knows how to do. You're just setting up like the colors and all that stuff. And then the spring is kind of new, but it came in the starter code. We're using a helix. And then more just telling it to plot a graph, which we always do. And so the first main part comes in when we're telling the curves, what curves to draw. And when we do the dk curve, that's kinetic energy. UG curve is gravitational potential energy. US is spring potential energy. And E is just the change in energy. And then, so moving on, then we have to do more of what we always do, including the ball mass, which is 0.402. And then the initial conditions, which are, for me, my first position in tracker was negative 0.118, comma, negative 0.6300, and the initial velocity is 0 as well. And then we get to a part in the code where we were told not to edit, but it's basically just taking the X and Y data from our tracker motion, and it's making a graph based off what we told it to. And then we do the time, and then the G, which is 9.8. The spring constant, which we had to find, is, for me, it's 6.83, and the L0 is 0.123, which it was given. And then we have to define the L and L hat. And after that, we have to plug in the formulas for the energy. So I'm not going to spend a whole lot of time, but that's basically just kinetic energy is 1/2 mv squared. Gravitational potential energy is mgh. Spring energy is 1/2 ks times s squared. And then the energy is just all three of those added together. And then we get our while loop, and I did my entire time, which was 8.262 seconds. And we do a lot of what we did up above, but now we're just, instead of the initial steps, it's like during it. And we have to calculate F net, which is just gravity plus spring. We have to do the velocity update formula and the position update formula, which is part of Newton's second law, which is velocity plus F net over mass times delta t for velocity. And then we go on to do more of the K, which is kinetic energy, and potential energy, all for while it changes. And then we tell it to plot the different curves. And then once we run it, we get all the different curves going. And you can see it looks just like the tracker motion. The graphs are a little interesting, which we're about to get to. And yeah, so now I do want to get to the graphs. The first question is the energy principle satisfied? And I said yes, because delta E equals 0. And if you add the DUG curve, which is the red curve, and the DUS curve, which is the green curve, and then you add all of those to the DK curve, which is blue, you get 0, which is the orange curve, which is the DE curve. And then for question 2, I got my Y data period to be 1.504 and the X data to be 1.652. And the only difference between those is really the X is just going from one side to another, but the Y has to go from one height to another, which isn't always the same in oscillating motion, so that's why those two are different. Thank you.